We're going to start chapter 2 with this nice review sheet. Has a few pieces of information that we already know. This is all the trig function definitions. This is just a table with all the information that we had already known about these quadrants in the coordinate plane here. If I go to the right, that's going to give me positive x's, which in turn will give me positive cosines and positive secants. When I go up, that's going to give me positive sines and positive cosecants, which when I do those two things, when we take and divide those two things, a sine divided by a cosine, we get the tangent. So if both of those are positive, then we get a tangent that's positive. So same idea, if I go left here, I'm going to get some negative cosines. And if I go with that negative cosine and I go up, then I'm going to get positive sines. But if I go down, I'm going to get negative sines. Okay? Negative y's and positive y's, kind of following along. Same idea with the tangents then. If I go and get a tangent where I take a positive divided by a negative, I get a negative. Or if I get a negative divided by a positive, that's a negative. Or if I'm down here in quadrant 4, I'm taking a positive divided by a negative divided by a positive, so the tangent's going to end up being negative, which in turn makes the cotangent negative. On this side, if I have two negatives, a cosine and a sine that are both negative, I'm going to get a tangent that's positive, which in turn is a cotangent that is also positive. So keep that in mind as you're going along. Some of the angles that we have all this information is just put into a different chart. This is kind of from the unit circle, all the different places along the unit circle at 0, 90, 180, and 270. And the sine, cosine, tangent values at those places. And ultimately, it's still the same idea that we're taking opposite over hypotenuse for sine, and we're still doing the adjacent over the hypotenuse for cosine. None of that stuff is different. Just put in a table a different way. When I look at the back of this has some of the trig identities. Actually, there's some of those on the front here. That kind of lead us into this section up here being 2.1a, and this section down here being 2.2. I guess probably 2.1b, you probably could use some of that information too at the top. But a 2.1b is going to be more solving trig functions, which is going to get you on the back here. So this is going to be more of 2.1b, looking at these identities. The top part of this, these are all identities that we already looked at, so there's nothing new in the top part of that. But the bottom part, we talked about these at one point, but now we're actually going to go through and we're going to use them. These would be the Pythagorean trig identities. So everything is like sine squared plus cosine squared equals 1 squared. We looked at those, where those things came from in a earlier section. But now we're going to go through and we're actually going to be using them to simplify trig functions. So let's take a look. We're going to start 2.1a with evaluating all 6 trig functions. We are looking in these right triangles still, so nothing's different about this. It's also similar to something that we had done in section 1.2, where we were naming all 6 trig functions. So the things that I need to decide what they are is sine of theta, the cosine of theta, the tangent of theta, just naming all 6 trig functions. And then I have cosecant, cant of theta, the secant of theta, and the cotangent of theta. And so when I go through, this is ultimately what my answers are going to be. I want all 6 of these. Well, some of these are filled in for us. They gave us the sine. They gave us the tangent. Okay, so I have 2 of those already, 2 of the 6. The other 4 are going to be built from this triangle. So I need to find out where my theta is, so I need to pick an angle to be theta. And it doesn't matter which one, just don't pick the 90-degree angle. Okay, we don't want to use the 90-degree angle. We're going to use one of the other two so that we can do some trig functions with those. So the first piece of information that we're going to look at is the fact that they gave us a sine. And I know that they gave the sine as the second thing that they gave, but when I look at the tangent is equal to 1. Well, that could be like 5 divided by 5. It could be the square root of 17 divided by the square root of 17. But any number divided by itself would give us a 1. That doesn't really tell us a whole lot about what's happening in this triangle as far as what numbers go on here. Where the sine does, the sine is equal to the opposite over the hypotenuse. And so once I name my theta, I have the opposite over the hypotenuse, square root of 2 over 2. Now notice that I drew the triangle in such a way that this theta down here actually acts like a reference angle. And so if I were to draw in an XY axis here, if my smartboard were on a little bit more, this angle right here is a reference angle. Okay, I'm going to take a second and try to straighten out the smartboard issue here. Okay, so hopefully that works out better for us. So I've got the angle that's a reference angle, kind of bringing back all the stuff that we're doing. It's in quadrant 1 because sine is positive and tangent is positive. And so I am using that piece from the previous beginning of this video that we were talking about. So I'm in quadrant 1 with the sine information on there. Now, from that, I could surely go ahead and use the Pythagorean theorem and go a squared plus b squared equals c squared to find out what this other portion is over here. And that would certainly work. Okay, it would certainly work for us to do that. However, we have another piece of information that we haven't used yet. We used the sine of theta. We haven't used the fact that tangent is equal to 1. And so tangent is the opposite over the adjacent. And that's going to be 1. Well, I've got the opposite. That was the square root of 2. And so in order for that to come back to be 1, the bottom of this has to be a square root of 2. And so this side over here has to be square root of 2. Okay? It has to work that way. It has to come out to be that the tangent is equal to 1. And so I go through and I can double check the information that they gave me to make sure that my problem is right here. So I've got the sine of theta is opposite over hypotenuse, square root of 2 over 2. That's good. The cosine of theta then is the square root of 2 over 2, adjacent over hypotenuse. Tangent is the square root of 2 over the square root of 2, which checks out to be 1, so that's good. The cosecant, I'm just doing reciprocals of these. So reciprocal of sine is 2 over the square root of 2, which I can't leave the square root of 2 in the bottom, so I multiply both top and bottom by that. Square root of 2 times the square root of 2 on the bottom gives me just 2. The 2's are going to reduce, and this answer for cosecant is just the square root of 2. Well, cosine is really the same exact work that goes into that when I flip it over, and cotangent, when I flip over 1, I only get a 1. Okay, so that's the answer for this problem is these 6 trig functions. It says to name the 6 trig functions. Okay, there's number 1. So on to number 2, they give us two pieces of information, the cosine being the negative square root of 3 over 2, and the tangent being the negative square root of 3 over 3. Again, I want to decide where I am on the coordinate plane. This time I'm in quadrant 2 because I've got a tangent that's negative and a cosine that's negative. Well, where does that come from? It comes from back here. I've got a cosine that's negative and a tangent that's negative. So I'm over here in quadrant 2. So my triangle is going to be over here with this being the reference angle. And so I kind of want to draw it so that it actually is kind of reflective of that, which I did. So now this is my reference angle right here. Okay, so that's going to be my theta. I've got a cosine in this, and I've got that tangent. That tangent is a hard one because you need to be careful about how that fits into the problem, where cosine is completely set up here so that this is adjacent over hypotenuse. Okay? But the problem is that I've got that negative on there. Well, again, I'm thinking about this on the coordinate plane, so the negative is going to go along the x-axis here. So this is going to be, the negative is going to be the adjacent part. So it's negative square root of 3, and the hypotenuse is going to be 2. Another way to think about that is the hypotenuse is always going to be positive because I'm taking two negatives, or two numbers, I'm squaring them, the two legs of the triangle, a squared plus b squared, I add them together, and then ultimately I can't get a negative back from that. So the hypotenuse is going to be positive no matter what. So again, we have the option of going ahead and doing the Pythagorean theorem, doing a squared plus b squared equals c squared, and coming out with this third side of the triangle over here. But again, there's another piece of information that we didn't use yet. We didn't use the fact that the tangent is the negative square root of 3 over 3. And so that negative square root of 3 over 3 is equal to the adjacent opposite over adjacent. Okay, so I've got opposite over adjacent. But the adjacent doesn't match up to what the adjacent actually was in this problem. And so the adjacent here is actually a square root of 3, negative square root of 3. So the negative part matches up, but it doesn't match up in terms of, well, what this tangent they gave us. These two things don't match up. The negatives don't, or the denominators of these don't match up. So that means that I had to do something to this in order to simplify it, which means I had to multiply by that radical in the bottom. So I multiply this by the square root of 3 and this by the square root of 3, which gives me on the bottom the negative 3. Now they match up. On the top, I have a square root of 3. I just need to check and make sure what number is in front of that. So now these two things match up as long as I had a 1 here. So I have a 1 on top of that fraction. If it was 2 square roots of 3 over this over 3, then I would have a 2 in front. Okay, I have a 1 in front. And again, if that didn't make very much sense to you, go ahead and use the Pythagorean theorem. It's going to give you a value of 1 anyway. And we know that the 1's going to be positive because, again, we drew our triangle in the correct way, and this y value is a positive, so it goes up 1. So the sign value of that then is going to be the opposite, which is 1 over the hypotenuse, which is 2. When I go through and I flip this over, 1 divided by 2 flipped over gives me 2 over 1. The cosine, I want to double check that comes out right. Adjacent over hypotenuse, negative square root of 3 over 2, that's right. I have negative 2 over the square root of 3 when I flip it over. Multiplying top and bottom by the square root of 3, I get negative 2 square roots of 3 over 3. The cotangent, when I flip that over, I get negative 3 over the square root of 3. Multiplying both top and bottom by the square root of 3, I get negative 3 square root of 3 over 3. The 3's are going to cancel, and I get just a negative square root of 3. So the cotangent value is negative square root of 3. Here's my 6 trig functions. 1, 2, 3, 4, 5, and then the last one we just did here, 6. And those are my 6 trig functions that's answering the question. On to number 3. So this one's actually going to be a lot easier. When I look at cosecant, cosecant is negative 5 over 3. That means that my sign is going to be flipped over negative 3 over 5. Well, I think we're more comfortable with sine being opposite over hypotenuse. My triangle with cosecant being negative and cosine being negative is down here in quadrant number 3. So my reference angle, my theta, is right here. I've got a negative 3 over 5, so the opposite is negative 3. The hypotenuse is 5. And that matches what my triangle looks like. They gave me the cosine was negative 4 over 5, so that's adjacent over hypotenuse, so this is going to be negative 4. Again, I'm going left on the x-axis, so it should be the negative. When I flip that over, I've got negative 5 over 4. Well, again, ultimately, I can just do sine over cosine to find the tangent, or the tangent is opposite over adjacent, so I get negative 3 over negative 4, which gives me just 3 over 4, and then the cotangent is 4 over 3. All of that stuff kind of fell into place just by the information that they gave us, and using some of the inverse trig functions that happen from that. Okay, and so then this is my 6 trig functions for number 3. So taking a look at this one, my theta, my reference angle, we're down in the fourth quadrant because cotangent is negative and secant is positive. So we're looking at the triangle here. A bunch of information is given to us. Secant is 13 over 5, so if I flip that over, I get 5 over 13. Cotangent is negative 5 over 12, so I can flip that over, and I can get negative 12 over 5. When I take a look here, I ultimately have all the pieces that I need, but cosine is adjacent over hypotenuse, so that's 5 over 13. Pythagorean theorem would get us the opposite side, but tangent is opposite over the adjacent, so that's negative 12 over 5. So all of the pieces were there from what I have, what I was given, if I draw the triangle in the right way. So then the sine is opposite over hypotenuse. It's negative 12 over 13. And I flip that over to, I get the cosecant, and then there's my 6 trig functions. Okay, take some time, go through this video, look back, make sure that you understand where the triangle is being drawn, which quadrant it's in, and then how these 6 trig functions happen. Well, when you are looking at homework, this is the questions where the questions are going to come from for the quiz. It's page 227, 1 through 14, all in your book. This is the quiz is going to come directly from these questions. It's not going to come from the notes sheet that I gave you. Okay, it's going to come from your book. That's where the homework problems are going to be. So page 227, 1 through 14, all. That's what we're going to work on in class when you come back.